Good evening, Srijita.
Good evening, sir.
In last class, we were discussing about the purification of the organic compounds. In that one, we completed crystallization method, sublimation method, distillation method, and here. Okay. Now, what is another method we are having means here? Chromatography technique. Okay. So, chromatography technique is that. So, by using the chromatography technique also, we can purify some of the organic compounds. Okay. Yeah. Chromatography technique. Chromatography. Okay, so chromatography. Actually, chromatography is the Greek word. Yeah. So chroma means color, graphy means writing. Okay, so chroma means here color, graphy means here writing. Okay, sir, who introduced the first chromatography technique means here first scientists. Okay, so TWESTT. Okay, generally we can call as a FET or some we can call as a FEST also. Okay, so he is a botany scientist. Actually, he is here botany scientist. So first he has done this experiment in the plants because of if you see plants means roots are having some color, stem is having some color. Okay, leaves are having some color and branches are having some color. So based on that one, he thought that some color pigments are present in a plants. Okay, so that's why first he has done the chromatography technique or chromatography experiment in the plants. Okay, actually chromatography is based on the adsorption process. Chromatography is based on here adsorption process. Okay, adsorption process. Okay, so chromatography is based on here adsorption process. Okay, so to complete the chromatography means here, so we have to know two terms for here. First, we have to know here two terms. So what are the two terms we have to take means here in this one? Stationary phase and mobile phase. Stationary phase and mobile phase. Stationary phase and here mobile phase. Sir, what is mean by the stationary phase means here? Stationary phase may be solid or liquid. Stationary phase it may be solid or liquid. Then what is meant by the mobile phase means mobile phase it may be liquid or gas. Mobile phase it may be liquid or gas. Okay, so mobile phase it may be liquid or gas. So based on this one, so again chromatography technique is classified into two types. Okay, so based on this one, so chromatography technique is classified into how many types here? Two types. Based on the stationary phase here and mobile phase, chromatography is classified into two types. Sir, what are the two types of the chromatography techniques we are having means here? One is called as a adsorption chromatography. Adsorption chromatography. Okay, adsorption chromatography. Adsorption chromatography. Okay, and another one is partition chromatography. So another one is here partition chromatography. So first one is how many types it is classified based on the stationary phase here. Again, at the chromatography is classified into two types. So one is adsorption chromatography, another one is here partition chromatography. Okay, in this one, what is meant by the adsorption chromatography? Okay, here again, adsorption chromatography also it is classified into two types. Again, adsorption chromatography also it is classified into two types. So what are the two types of the adsorption chromatography? It is that means here. One is column chromatography. One is column chromatography. Column chromatography. So another one is having TLC. So TLC is nothing but thin layer chromatography. So TLC is nothing but here thin layer chromatography. So one is called as a column chromatography and another one is called as a thin layer chromatography. So how we are going to do the experiment and at all? So what is the main important thing? By using this method, we can separate the mixture of components into individual components. Okay, so what we are doing here? So by using this method, we are going to separate the mixture of components into individual components. Okay, now just I want to show some diagram. Just wait here. Okay. So then only it is visible. Right. So now I'm going to share the screen here to show you something. Okay. Now you can check it out. Okay. Now we can check it out here. So clearly, first one. So this we can call it as the absorption chromatography. Sir, what is meant by the in absorption chromatography? We are going to study about here column chromatography, sir. Sir, what is meant by the column chromatography means here the longest glass tubes are we can call as a columns. The longest glass tubes are we can call as a column. Okay. So see that you got the screen or not? First of all, you give me the clarity.
Yes, sir, I can see.
Okay, you are able to see the diagram now here. Okay,
Yes,
so
sir.
the two diagrams are there in this one. Okay, now first one, so check it out, ma. So in this one, the longest glass tube is called as a columns here. So this we can call as a column chromatography. So in these glass tubes, first what we are going to fill means we are going to fill as here silica gel or alumina. Okay, so silica gel or alumina as they act as a good absorbent. They act as here good absorbents. So after filling a silica gel or alumina, so we are taking as a some capillary juice. Sir, what is meant by the capillary juice means if you crush the leaves, we will get as some green color liquid. The green color liquid only we can call as here capillary juice. The capillary juice is placed on the top of the column. Okay, so the mix here, let us see here. The mix containing the components of X and Y. How many components are there mixture here? The mixture is containing here X and Y. Now, so after placing the capillary juice on the top of the column and we are passing the solvent through the column. Okay, if you pass the solvent means along with the solvent, so what are the color components are there, that is also travel towards to the downside. Okay, and in this one the component which is having the low molecular mass, it travels long distance from the baseline. The substance which is having the high molecular mass, it travels less distance. Now after passing the suitable solvent continuously, it generates the chromatogram. Okay. Now in the second diagram, you can observe here, after passing the column, we can observe two colors in the column here. What are the two colors are there? One is white, it is there. One is green color, it is there. Another one is purple color, it is there. Okay. Another one is here, violet color, it is there. Okay. Now, sir, how we can remove these two colors? How we are going to separate these two colors means we have two methods. So what are the two methods we are having means here? So first one is we have to pass the solvent continuously. When you passes the solvent continuously means the columns are having tap downside here. If you release the tap and continuously if you flow the solvent means, okay, along with the solvent some substance it comes outside that we are collecting in a one receiver. Okay, after removal of the complete one color, again, if you pass the solvent continuously means one more color we are going to be collected in another receiver. Okay, so by using this method also we are going to be separated the mixture of components into individual component. Okay, the passing of the continuously solvent. Okay, if the solvent is passes continuously through the mixture to pass to separate the individual components means the process is called as a elution. So what is the name of the process means here? The process is called as a elution. Okay, and what is the another method we are having means here? Simply after generating the chromatogram, we are breaking this glass. After breaking this glass, directly whatever the substance it is there, that wherever the color is generated, that part we are going to be cut. That part we are cutting with the knife, and that whole substance we are placing in a suitable solvent. Sir, where you place the suitable solvent means here, in suitable solvent, the substance is completely dissolved. And alumina or silica gel can be separated by the filtration method. Again, it undergoes to the evaporation method means, okay, crystallization method means it forms as a solid substance. Okay, now we got the clarity.
Yes, sir.
Okay, next. So thin layer chromatography is there here. So what is the second experiment means here? Thin layer chromatography. So what is mean by the thin layer chromatography means here? First of all, we are taking as a some glass plate. First of all, we are taking as a some glass plate, which is having 20 centimeters length and 5 centimeters weight. Okay. On the glass plate, we are coating the silica gel or alumina. How much thickness we are coating means 0.2 mm thickness we are coating here. How much thickness we are coating? We are coating here 0.2 mm thickness, we are pasting the silica gel or alumina on the glass plate. That is only we can call as a TLC. Okay. After taking this one, so that is only middle part one. It is then a glass pot. Okay, in middle one. So that we can call as a TLC. Okay. So after pasting the silica gel or alumina from bottom onwards up to the 5 centimeters length, Mahia, up to 5 centimeters length, we are drawing as a some baseline. Okay, we are drawing as a some baseline. After drawing the baseline, at the center, we are going to inject the capillary juice. We are going to inject the capillary juice. And this whole setup we are placing as a closed container. We are going to place in a closed container which contains the suitable solvent, which contains here suitable solvent. And that is also how we have to place, means here wherever you draw the baseline, that it is not dipped into the solvent. If it is dipped into the solvent, means the substance, it is not possible to separate the mixture of components into individual component. That whole substance is dissolved in the solvent only. So that's why, so slightly from bottom part only, slightly it has to dip in the solvent. And if you close the container and if you leave for some around 1.5 hours to 2 hours, 1.5 hours to 2 hours means you can generate the chromatogram. If any color components are there, means you will get this kind of color spots. You will get as here this kind of color spots. Okay. Otherwise, if you are unable to find any color spots on at all, you can see under the ultraviolet rays here. Okay, if we see under the ultraviolet rays, means we can find out some color spots. Even in that also, if you are unable to see, means again we have to place the chromatogram into the iodine chamber. Then only it generates the color spots. Okay, this is the one method. Sir, in this method also, how we are going to be separate, means here we have a one RF factor. Okay, so we have here some RF factor. Based on that one, we are going to separate here mixture of components into individual component. So what is meant by the RF factor, means here RF factor is nothing but the distance traveled by the substances from the baseline, and the distance traveled by the solvent from the baseline is called as a RF factor. RF factor is nothing but it is the ratio of the distance traveled from the solved substance from the baseline. Okay, and the distance traveled by the solvent from the baseline is called as a RF factor. Okay, so clearly here there. And what is the another one we are having, means here partition chromatography. Okay, partition chromatography. So in thin layer chromatography, column chromatography, stationary phase is the solid, mobile phase is the liquid. What is the stationary phase we had taken, ma? In thin layer chromatography and partition chromatography, column chromatography, we had taken as a solid is the stationary phase. In partition chromatography, what is the stationary phase, means liquid, and what is the mobile phase, means mobile phase is also it is liquid. So that's why partition chromatography also we can call as a liquid chromatography. So what is the best example for the liquid chromatography, means here paper chromatography is one of the best example for her liquid chromatography. So which one is one of the best example, my here? Paper chromatography is one of the best example for the liquid chromatography. Clear? Okay.
Yes, sir.
Let us see here in this only. Okay. Again, sir, how you are going to generate the paper chromatogram? How you are going to do the experiment, means here? However, we had done TLC. Same thing only. In place of TLC, we are taking as a paper. So paper is which is made up of the cellulose. Okay. So actually, we can take as a filter paper. Which paper we can take, ma? Filter paper. Some blue color paper. It will be there in laboratory. Okay. That filter papers we can use to do the paper chromatography. Okay. Now you may get that out. Sir, paper is made up of solid only, na? Actually, paper is the solid substance. But you are telling that partition chromatography is liquid chromatography. How it is becoming as a liquid chromatography? How it is becoming as a liquid chromatography is paper is made up of cellulose. Cellulose is example of the carbohydrate. Okay, so carbohydrate is nothing but, so what is the definition of the carbohydrates, means it is hydrates of the carbon is called as a carbohydrate. That means it contains a more number of water molecules. So due to that reason only, partition chromatography is called as a liquid chromatography. Okay, for that one I'll tell one example. Are you using ballpoint pen or ink pen, ma'am? Srijita.
Repeat, sir.
So Are you using ballpoint pen or ink pen?
Ballpoint pen.
Ballpoint pen. Have you used any ink pen?
Yes, sir.
Okay. So actually, whenever you're using ink pen, in our side, actually we use some rub books. Rub books are light blue color, it will be there. Okay. Or light cream color, it will be there. Is it right?
Yes, sir.
Okay. If you place the ink pen on that paper, means what happened? Ink is going to be spread throughout the paper. No?
Yes, sir. It bleeds through.
Yeah. So why it is going to be spread, Sma? Why it is going to be spread?
Is it because of the cellulose?
Because of cellulose. Okay. At the same time, same if you place one drop of the ink in water. Okay. If you place one drop of the ink in water, means here that whole ink is going to be distributed throughout the water. Is it right?
Yes, sir.
Okay, so that means here paper is containing more number of water molecule. So that's why partition chromatography is called as here. So liquid chromatography. Okay, so by using the partition chromatography, which substances we are going to be separated means here, especially amino acids. Amino acids can be separated by the partition chromatography. After generating the chromatography, if you are unable to find out any color spots on the paper means we have to spray the ninhydrin solution. Ninhydrin solution can be sprayed in the detection of amino acids. Okay, so which solution we are going to be placed, ma? Ninhydrin solution we are going to be placed in the detection of amino acids. So now you got the clarity.
Yes, sir.
Okay, so all these are the different cryptography techniques we are using to separation of the mixture of components into individual components. Okay, next, so we'll check it out some qualitative analysis method. So what is the next concept we are having means here? We have a qualitative analysis. Okay, qualitative analysis. Qualitative and quantitative analysis in chemistry. That is the concept that whenever we get a notes on it. Right. So here only I'm going to be explained because of some formulas, everything they may be given here. Yeah. So what is mean by the qualitative analysis and quantitative analysis means here? Let us see. First, qualitative. So first they had given us a quantitative analysis. Before going to the quantitative analysis, first we will go for the qualitative analysis. Okay. So what is mean by the qualitative analysis means here? Detection of elements. Okay, so detection of the elements is called as here qualitative analysis. Sir, how we are going to identify the elements and that all means here by using some of the chemical test, we are going to identify the sum of the element. That is only we can call it as a qualitative analysis. Okay, so quantitative it got a right. So let us see here. So last sign test not all mainly for this purpose only I open this. Yeah. Right, ma. Here detection of the elements. Detection of the elements by using some of the chemical reactions is called as a qualitative analysis. Okay. So actually you had done some practicals. Okay. Salt analysis part you had done. You had done or not, Sriyuta?
Yes, sir.
Okay. You had done only now. So in the practicals, ma. So what we had done here? So detection of the cations and detection of the anions. Okay, so identification test of the cations and identification test of the anions. In the detection of the cations and anions, we use some of the chemical reaction. Okay, so that is only we can call as a qualitative analysis. Qualitative analysis is nothing but here it is the detection of the elements by doing some of the chemical reactions is called as a qualitative analysis. Okay, so by using that one, we are finding out some of the elements. What are the elements we are going to be find out means here we are going to find out carbon, hydrogen, nitrogen, sulfur, oxygen, phosphorus, halogens, chlorine, bromine, iodine also we are going to be identified. In this one, detection of the carbon and hydrogen is very easy. So first we are taking as some amount of the organic compound. That one is heated with the cuprous oxide. That one is heated with here, cuprous oxide. If it is heated with the cuprous oxide means here, in this one, carbon is converted into the carbon dioxide and hydrogen is converted into the water molecule. Okay, whatever the carbon dioxide it is there, that it is passes through the lime water. So when it is passes through the lime water means it is converted into the milky white. How it is going to be converted, ma? It converted into milky white. So that is the one identification test of the carbon here. And water molecule. Sir, how you know whether the given organic compound is containing water molecule means after heating with the cupric oxide, hydrogen gas is converted into the water vapor. That water vapor, sir, passes through the anhydrous copper sulfate. If it passes through the anhydrous copper sulfate means, so that time the copper sulfate it becomes as a blue color. If it becomes as a blue color means based on that one we can say the given compound is containing hydrogen as a element. Got the clarity? And how you are going to detect the nitrogen, halogens, sulfur, and phosphorus means here that we are going to be identified by the Lassigne's test. How we are going to identify, ma? So by using the Lassigne's test, we are going to be detect here. So nitrogen, sulfur, and all. Sir, what is mean by the Lassign test and all? Sir, how we are going to do the Lassign test means here? First, we are taking fusion tubes it will be that, like your pen refill it will be there na? Like that some glass tubes are there in laboratory which is open both sides. So how much length it is required for us until that we are going to be break, and one side if we heat strongly means that side it is going to be closed. After closing one side, in that one we can insert some sodium metal. First what we are doing here, we are inserting some sodium metal in a fusion tube. In that only we are taking small amount of the organic compound. After taking the small amount of the organic compound, we are heating until to red hot. Okay, if you heat glass means you will get as some red color flame. You know that one?
Yes, sir.
Okay, until that you have to heat, ma. Okay, so after heating until to the red hot, okay, after heating until to the red hot, okay, that we have to place in a mortar and we can crush it. We can make into the finely divided powder. After making into the finely divided powder, we are pouring some 10 ml of the water. Okay, how much amount of the water we are placing here? 10 ml of the water. Okay, that after that we are doing the filtration. If we do the filtration means here glass particles are present on the filter paper, and whatever the liquid it is that we can call as a Lassign extract. By using that one we are going to do the other test here. Okay, now in this one, first one. So here if you see means what are the elements we are going to be find out? We are going to find out the chlorine, bromine, iodine. So chlorine, bromine, iodine are present in the form of sodium halide. And sulfur is present in the form of here sodium sulfide. Okay, and nitrogen, so nitrogen is combines with the carbon because of organic compound is containing mainly carbon is the major element now. Organic compound is containing carbon as a major element. So carbon and nitrogen combined together means forms as a sodium cyanide. So first experiment my here. So what is the first experiment is detection of the nitrogen. Sir, how we are going to identify the nitrogen means first we are treating Lassign extract with the freshly prepared sodium sulfide. Freshly prepared sodium sulfide, sodium sulfate. It is converted into iron ferrous cyanide here, hexacyanoferrate. Okay, it is converted into FeCN taken 6 times. Okay, again, what are the iron cyanide it is formed here? That again it is treated with excess of sodium cyanide and presence of dilute sulfuric acid means finally it gives us a Prussian blue color. So finally, which color you will get, ma? Prussian blue color precipitate. In this one, concentrated sulfuric acid is act as an oxidizing agent. It oxidizes the Fe ions into Fe3 plus ions. Second step, once you checked it, ma. What is the second step? It is the concentrated sulfuric acid is it oxidizes the Fe plus 2 ions into Fe3 plus ions. Okay. And again,
Yes, sir.
FeCN6 taken 4 times, it is reacts with the Fe3 plus ion and it gives us a Prussian blue color. We got as a Prussian blue color mean that indicates the presence of nitrogen in a given organic compound. Okay, this formula they're asking in the examination formula. What is the molecular formula of the Prussian blue color? What is the molecular formula of the Prussian blue color? Fe4, FeCN taken 6 times and H2O is called as a Prussian blue color. Clear?
Yes, sir.
Okay. And so what is that? They're asking some name also, IUPAC name also they're asking here. Ferrocyanide also is called here. Ferrocyanide is the IUPAC name of the given complex. Okay. And second test, detection of the sulfur. So first we are taking as 1 ml of the sodium extract in a test tube. Okay. Again, we are taking as 1 ml of the sodium extract in a test tube. For that one, we are adding as a sodium nitroprusside. So whenever you added sodium nitroprusside means it is converted into violet color complex. It gives us here violet color complex. If you got as a violet color complex means that indicates the presence of the sulfur. Okay, that indicates the presence of the sulfur. And test for the halogens. Sir, how you are going to do the test means here for that lysine extract only. Already you had done the test. Detection of the halogens. How you had done the test, confirmation test halogens in the laboratory? You didn't remember, Sriyuta? How you had done the confirmation test?
Sir, I don't remember.
You didn't remember. So actually we are taking a sample solution. For sample solution, we are adding as a aqueous solution of the silver nitrate. Which one we are adding, ma? We are adding as a aqueous solution of the silver nitrate. If you add aqueous solution of the silver nitrate means you will get as a white color precipitate, light yellow color precipitate, yellow color precipitate. For example, if the given organic compound is containing chlorine, if it is containing chlorine means here, okay, you will get as a white color precipitate. That indicates the presence of, okay, that indicates the presence of the chlorine in a given organic compound. If you got as a pale yellow color precipitate, we got as here pale yellow color precipitate. If you got as a pale yellow color precipitate means that confirms presence of, okay, that confirms the presence of bromine in an organic compound. Okay, if you got yellow color precipitate means that confirms the presence of, no, that confirms the presence of iodine. Okay, that confirms the presence of iodine. So right, let us see. Here they had given. So if you got as a white color precipitate, that white color precipitate is soluble in ammonium hydroxide. If it is soluble in ammonium hydroxide means it indicates the presence of the chlorine in a organic compound. Pale yellow color precipitate if you got as a pale yellow color precipitate means that is sparingly soluble in ammonium hydroxide. That indicates the presence of bromine. Okay, and yellow color precipitate. Okay, if it is yellow color precipitate means here, if it is insoluble in ammonium hydroxide. If it is insoluble in ammonium hydroxide means it indicates the presence of iodine. Got the clarity?
Yes, sir.
Okay, so that is the identification test of the halogens. And sulfur identification test is there. Detection of the sulfur. So how we are going to identify it means here, first of all, sulfur, whatever this, sorry, phosphorus. Sulfur already we identified now. Okay, next
Yes,
we are
sir.
taking as a phosphorus. Phosphorus is present in the form of phosphate. How it is present means here, phosphorus is it is present in the form of phosphate. But the phosphate, if you add freshly prepared ammonium phosphomolybdate, freshly prepared ammonium phosphomolybdate. You will get as a yellow color precipitate. If you got as a yellow color precipitate, means that indicates the presence of here phosphorus. So all those are the different tests. Okay, based on this test, again we are doing confirmation. How much percentage of the nitrogen is there? How much percentage of the copper it is there? And how much percentage of sulfur and how much percentage of the halogens are there? That we are going to be identified by the quantitative analysis. That we are going to be identified by quantitative analysis. Sir, quantitative analysis is nothing but estimation of the element. That means how much percentage of the carbon, how much percentage of the hydrogen it is there, that we are going to be calculated. So for that one, so actually this one is very important concept one. This chapter also, this one is very important concept. Compulsory based on this concept, if you go for the CET level or MSET level also, they're asking one question guarantee. NEET level also they're asking one question is a guarantee. Guarantee 1% it is there. Okay, so what is the formulas? These formulas we have to remember. Okay, so same experiment only. What is the name of the experiments also they're asking? Detects estimation of the carbon and hydrogen we are using as a Liebig's method. What is the name of the method we are using in the estimation of the carbon and hydrogen? Means we are using as a Liebig's method. Okay, sir, how we can calculate the percentage of the carbon? Means, sir, these formulas we have to remember. What is the formula is that to calculate the percentage of the carbon? Means 12 by 12 into mass of the carbon dioxide formed by, okay, 44 into mass of the substance. Okay, so 44 into mass of the organic compound we had taken in the experiment. Okay, so we are calculating the percentage. Percentage means we have to multiply with 100 only now. Okay, we have to multiply with 100. So that's why we can write as 12 by 44 into mass of the carbon dioxide formed by mass of the organic substance taken in into 100. If you multiply with that one means you will get the answer. Okay, here for second one percentage here they had given formula is wrong. Actually 2 by 18 percentage of the hydrogen is, so 2 by 18 into mass of the water molecule formed by mass of the substance into 100. So by using this formula, we are going to calculate the percentage of the carbon and percentage of the hydrogen. Okay, next.
Yes, sir.
What is another one means here? So estimation of the nitrogen. Estimation of the nitrogen, we are using as a two methods. What are the two methods? Means one is the Dumas method, another one is Jaldal method. Okay, so in Dumas method, what is the formula we are using? Means here percentage of the nitrogen is equal to 28 by 22,400 into volume of the nitrogen at NTP or STP by mass of the organic compound into 100. Okay, my name said, and NEET level formula oriented questions only they're asking. Which question they're asking here? Formula oriented questions only they're asking. So formulas are very important that you can remember. Okay,
Yes,
clear?
sir.
Right now, and Jaldal method also it is there. So Jaldal method is not applicable. By using the Jaldal method also we can detect the percentage of the nitrogen. Okay, and estimation of the halogens. What is the name of the method we are using? Means Carrier's method. By using the Carrier's method, we are going to be identify the percentage of the halogens here. But directly, simply, I'll tell here. Better in your textbook that given as a formulas clearly. Okay, that given as a formulas. If you learn all the formulas means here, so it is very easy to calculate. Now we got the clarity, ma.
Yes, sir.
Okay, so this is about GOC. So GOC also we finished here. Okay, yeah. So
Yes, sir.
just take one. So Sunday you have a test based on complete organic chemistry. Okay, Sunday
Okay,
you have
sir.
a test based on here complete organic chemistry. Whatever we discussed until today, all concepts are there. 30 marks only. Okay, but
Okay,
30
sir.
marks only you are having test. So better to prepare complete GOC. Okay, Next tomorrow, we start about the hydrocarbons. If the hydrocarbons is completed means 11th portions are completed.
Yes, sir.
Okay, 11th portions are completed. Okay, so 12th already we discussed about 2 chapters. Okay, so briefly, I'm going to complete the 12th syllabus also. Okay, ma?
Okay, sir.
Okay, right. So we'll continue in the next class. So thank you.
Thank you, sir.
Welcome.